Okay. So last week when we were looking at our web server application, we were doing some refactoring to actually get this a little bit more in line with the project that we created, the sample web app project. Because before, what we did was we didn't actually have kind of the web server project set up. We wrote a script that would introduce Hunch and Toot, but we didn't actually kind of isolated into a single application that needs to run. So now, let's say that you want to be able to run this inside of a container. Okay, you want to create a set of services that runs inside of Hunch and Toot. So this is the next step above, right? You want to be able to take an executable and create an executable that represents a single service. Okay.
Yeah, that would be cool.
Okay.
And I haven't really dealt with the environment, like getting things to run in my Emacs thing, basically since last week. So
Right.
time flies.
So,
So my setup is in the same state as it was last week, where I think
no,
we didn't
perfectly all
actually
right.
get it to
So
run.
I just fixed it up like in 5 minutes, like right now, because I knew what to
Okay.
do. But it required me to go look up one thing on Hunch and Tooth that I completely forgotten.
Okay.
Okay.
So I'll try to make the
Um,
same changes on mine.
right.
I'll switch back
So
and forth
let me
to
let
look at
me let
yours.
me explain first what happens in Hunch and Tooth when
Sounds
we
good.
run start, because I think that's an important thing most people need to realize when I show them the code.
Okay.
So in Hunch and Tooth is inherently multi-threaded. Okay,
Okay.
shouldn't not be a surprise to anybody who's dealt with web servers. Web servers are inherently multi-threaded. Even Apache is multi-threaded. Each socket request ends up going to a separate thread for execution and response handling. Longitude is no different. It starts up essentially a Bordeaux thread in the background, which is really a wrapper around the threading environment for the given Lisp distribution that you're using, and it'll fire up your web server. So the cost of this is if you were to use the build script that we created last week, which I renamed to sample web app.ros. This is so that when we create the actual final executable, it's named sample web app um, instead of build, and that I which is what we had last week.
Oh, okay.
Um, it will actually be blocking. Okay, if you actually built the sample web app.ros without what I'm going to show you next, what
Yeah.
ends up happening is when it gets executed, it will just start up and shut down. Okay, because what happens is it forks off a thread. Threads are non-blocking. The program exits because it's returned zero. It doesn't have anything to. It's not looping or anything in an infinite
Okay.
loop.
And then
So
the thread just gets
so
recovered.
the thread joins and then it just gets
Oh,
killed.
okay.
All right. So
Thread is kill.
yeah. And so what you have to do to address that is you need to do the following, which is in your main.lisp that start web server, after you start the web server, you actually have to write a handler case here. The
I
reason why
see.
you need to write a handler case is you can't just simply do a sig abort on a loop, because that actually throws effectively a Lisp condition, and it will throw barf up a whole stack trace before exiting the Lisp image. All right. So to address that, you need to wrap this simple loop of essentially sleeping the main thread for a second every now and then. So that way, in the bottom level condition, if any sort of signal comes from the Unix environment, it essentially just returns nil so that this function exits properly and the program can clean up and the Lisp image can clean up properly. All right. So
Okay. So
this
this
live,
is in a loop sleeping for a second
right.
because if it didn't sleep for a second then and it instead did a no op or
If you did it this way, I'll show you what it was before. Okay.
okay.
If you did it this way,
Excuse me.
okay,
Uh
Hunch and Toot start, okay,
yeah, that's what I had.
yeah, Hunch and Toot start will start a thread, exit. This function exits. The main program, which we wrote here, exits, and then the thread joins.
No, yeah, I got that part. But then you were saying that it doesn't work. So to avoid having the main thread or the main uh, process get to the end,
Yeah,
you have to have a loop. Um, but you
right.
can't
And
just
that's why
have a
there's this
loop
loop
with
here.
a you can't just have a loop with a no op. You have to have a loop with a sleep 1000 for some reason.
Well, you can have a loop with the no op. It's just that it's not loops with no ops because the main thread will take precedence. It's
Yeah,
going to overshadow the listening socket. By sleeping it for a second, you're allowing Hunchintoot to go and handle requests. So you could
I
allow the scheduler to actually go in and switch it to the other thread,
I
right?
see. Let me compare that to. Can you see my code I'm sharing? I actually did. My code is
Yes.
still slightly different, even from the bear thing that you had. I don't have this sample web app colon
You mean sample
star
web app
web
dot server colon web
server.
server?
Yes, sample web app. You're right. Dot server.
Yeah.
Uh, web server, and then I guess I'll just add in the other stuff that you had, or that
Yeah.
you have. Handler
Like
case
I could show you what happens here what when if we
loop
just do loop here. Okay.
loop
Um
do uh sleep 1000
run
condition
sample.
nil.
Okay. Let me go to my
Uh,
terminal here.
okay, and I'm
Add
bringing you
another
back.
terminal. Do a curl, right. Everything everything
Hey,
seems to
Dave.
work with yeah, everything seems to work. But if we go here and we do a control C, do you see how it just I
It
had to
sat there
like
for a second.
hit it, yeah, it sat there for a couple of seconds. Whereas if you had the sleep here, it's almost when you after rebuilding it, because I'm basically rebuilding the Lisp image, and
Gotcha.
then you execute. If
And
I
then if
do
you hit
that,
Control
it's
C,
instantaneous.
that is the exact opposite of what I would expect. What? So the sleep is letting the
Because
main thread
of Lisp. The Lisp
go
thread
to
has is
sleep,
right.
and therefore other threads can handle the signal immediately.
Right. No, like no, I misspoke. Like this guy here, okay, if you had this,
Yeah.
okay, and you built it, the handling works, but the shutdown takes a long time. This will
Yeah.
handle graceful shutdown because the Lisp image recognizes the signal
Uh huh.
because loop is constantly running and right? It's an infinite loop. It's taking precedence, right? It's doing nothing, right?
Oh. So it's
So,
like eating up all the resources, so it takes
right.
longer to handle the interrupt
Yes,
or the
exactly.
signal, whatever the signal is.
Right.
Okay.
It's the same thing that sometimes happens when you run like a long computation that's in an infinite loop in like a C program. Like sometimes
Or
you
in
get that
JavaScript
situation
even,
or JavaScript,
and then your
right?
page locks up.
Right. You have to
Yeah.
you have to you have to you have to kill you literally the only option is to do a kill dash 9, which is a major abort. It's not a graceful shutdown. Control
Kill
C won't
dash
work.
nine. No more CPU time.
Right, exactly. You don't want to do that, right? That's just nonsense. Okay. That's
Good
just
times.
nonsense. So
Um.
this addresses that. This
So
this graceful shutdown.
yeah. So every once in a while, every second, waking up for just long enough to continue the loop doesn't take up very much in the way of
Right.
resources.
Exactly.
I'm surprised there isn't some like, I don't know, just park forever. Don't exit. Like, is there not something
There
like that?
Well, this is the way Lisp works, right? Because you're running these live objects in an image. You got to think of Lisp as a. This is why a lot of folks call Lisp being an operating system, right? because you are starting these data structures, these objects living in your actual running image, right? Parking anything will prevent interpret other commands from being able to run in your interpreter. Now, if you're talking about from the state of an application, that's true. That's necessary. That it should be possible. I just don't think SPCL's save Lisp and die gives you that option.
I'm just so okay, but like, what if instead of sleep 1,000, you did sleep 1 gigabillion?
It
Then
doesn't. I
what?
don't think it matters. Then I don't think it matters.
What
Even
if
if we did it to
what if you said
1 million.
sleep for more time than there is left in the universe?
Well, at that point, the main thread, just
I feel like
won't do anything. It'll we do
so
that.
so
Okay, and
I
we do
guess
this.
that's like a hacky way to do the just pause here,
Right.
I guess. Um
Well, you have a pause even in standard. If you think about standard C, right? When you
uh-huh.
write a server in C,
Yeah.
almost everybody ends up writing essentially a while true, and then using and then writes the signal handlers to essentially address all the signals that you would deal with graceful shutdown.
Yeah.
And
But the while
the
true, isn't that usually l- waiting for something on the port,
the
like
main thread.
some yeah. So
Yes,
it's
that's
it's
true.
not it's not just like not doing anything. It's waiting for the accept to
Yeah,
do something
it's waits
to
until socket
return.
accept gets a socket,
Yeah.
and it's always listening. After you listen, it's always the first call to listen essentially throws up this thread that's going to handle sockets and hands over the socket resource to the main thread, and that socket accept is what's handled in the while true to hand it off to another thread to actually do the handling.
Yeah. Is
Okay.
there okay? So if I want to get
So,
my
by the way,
thing, yeah.
all this stuff can be done if you wrote the socket accept code, but Huntington handles all that in its acceptor object that we created in
Ah.
webserver.lisp. This
Okay.
easy acceptor does all that socket accept and all that stuff related to the stuff that you're talking about. Okay.
Okay.
The
Can
only
you go?
thing that is different. What?
Can you go to the top of main.lisp and I'll
Yeah,
compare it
sure.
to mine just to make sure that there's nothing different there. UIOP define package sample web app use CL export web server start web server. Yeah. Okay. Cool. That all looks the same. And then the next file that you went to is the web server.lisp.
Right.
And then I'll turn on line numbers. Oop. Uh, okay. Define package sample web server sample web app dot server UCL exports web server.
Forgive my
Yeah.
indentation. Stupid Visual Studio Code does not do indentation right for this plugin does not do indentation right. So
Gotcha.
I've been
Define
going through and
package
fixing indentation.
def parameter easy acceptor port 8003. Whoa. Hunchin toot start web server.
Get rid of that.
Oh, I
That's no
can
longer
get rid of
required.
that. Yeah. Okay.
Yeah.
Just kidding. So that part is now handled
In the main.lisp.
in the main.lisp. Okay. And then define easy handler say yo to the URI to Yuri, our Russian friend Yuri. Set F Hunchin to content type. Uh, is content type supposed to have a
A
star
star, yes.
just at the end? Okay.
Yes. That's
Text
a Hunch
plain.
Intuit style. That's not
Okay.
um
It
that's
looks
part of the
like.
Hunch Intuit API. So if you go and look at this, like
What does
uh
star just at the end mean? Is like when do you use that as opposed to star on both sides?
okay. Earmuffs means you're dealing with effectively a dynamic variable,
Yeah.
okay? Or global variable if you want to be very explicit about it. Technically, it's not a global because
It's a parameter from Racket. Uh, yeah, a dynamic. I think a dynamic. I don't think there's a more
so
succinct
the
way to put that.
the best way to explain dynamic variables is they are Lisp level environment variables. All right. If you're looking
Yeah,
at the context of a single
sounds good.
global Lisp environment, then they are global variables. But if you're using multi-threading in Common Lisp, then you can use dynamic variables to do thread local storage, to mimic thread local storage. Have you ever handled thread local storage? Do you know what I'm talking about when I say thread local storage?
Um, a variable that each individual thread has its own little
It's
version
ownership.
of.
Yes,
Yeah.
it's ownership. It owns it within the context of that thread. Those dynamic variables are placeholders that can give the thread ownership to a particular section of memory.
Oh. Okay. I was thinking dynamic as in dynamic scope, but that
It is
sounds
dynamic scope, but it's not. It's the dynamic scope versus lexical scope. Dynamic scope is within the context of the environment that it's been bound to, right?
oh, dynamic scope within a thread.
Yeah,
Okay.
that is right.
Okay.
So
Uh
so lexical scope is within a function or a body. Okay, usually dynamic scope is you're defining the scope in which this variable is going to reside in. So in threads, it's within the scope of the thread. In the process, it's within the scope of the process. There's no strict definition on it. There's
gotcha.
no
Huh.
so versus this star comes to a pattern in Common Lisp APIs
Okay.
where if you're going to have potentially um, additional forms that depend on the previous form, you use the star operator in your executable your exported API. So your content header, content type is part of the content header information. And so the star is basically saying that some later thing could depend on the content type, this content type. So I'm going to have to, I'll have the ability to modify it. You'll see a lot of them here. Like if you look here,
Okay.
content
So it's
here.
saying that it could be modified later.
Yeah, it could be previous forms could depend on the sorry, next forms could depend on the previous form.
Okay.
So like in our case, we could have used just simply content type here
Yeah.
because there is content type and content length. But if you wanted to do like think let versus let star, okay? And
If we,
I think Clojure has let versus let star too as well. Um,
uh
uh,
Closure just has let star and they call it let,
okay,
but
got it.
it's let star from all the other
It is let star.
things
Okay.
that have let.
So in Scheme, I know there's I think a let and let star, um, but that's a Lisp heritage that Scheme inherited. Um, and so
And then,
let
well, yeah, there's also like OCaml has let rec. I think it also has a let star.
right,
It's
yeah,
the it's
but the idea is all
the
the
good
same,
one.
though, Daniel. That's what I'm trying to say. Like let
Okay.
basically in the purest Lisps out there, of which Common Lisp is one of them. Let means no variable can depend on each other. Each variable is independently defined.
Yeah.
Okay.
Okay.
Let star allows you to define variables where one depends on the previously declared variables.
Yeah.
Okay. So that's the difference.
Uh, let let rec does that, and then I think doesn't let star allow in both directions. You could have like A depends on B and B depends on A.
I've
for like
never tried A depends on B and B depends on A with Let's Star. That is an interesting question. I don't know because
I
at some point there's going to be a cycle there, right? And that would
yeah,
just probably
so
mess things up.
you have to have a way that you could actually have this mean something is if a and b are both functions. So like an example that
Right.
I've seen a few times is so that the body of the function doesn't necessarily get evaluated immediately, but the body of a depends on calling b, and then the body of b depends on calling a.
Right.
So then you
That's
could have
true.
something
And
like
yes, in terms of if they are functions, then yes, what you're saying is absolutely right. Let's Star does allow you to do that cyclical definition. In fact, that's the basis for metacircular interpretation.
yeah, okay,
Yeah.
cool. Yeah, so that's my understanding of the difference between let rec versus let star is that let rec only lets you do nested things, so like later things can depend on previous things but not
Right.
the other way around, and then let star lets you go in all directions. um,
So let rec is closures. Let rec is what you're talking about, right?
Closures let, like closure, in closure you would type out just let, and then but that
Okay.
would mean let star.
Oh, you're talking about OCaml. OCaml's let rec, right?
I think OCaml's let rec is the same let rec as Common Lisp. I think OCaml
Right.
maybe also has a let star. I don't remember.
Right. So let I know with let rec, I thought that that also allows you to define recursive definitions. Um, one of the
Yeah.
reasons why.
Oh yeah. You're right. So maybe yeah. Then I guess let rec in OCaml must
So
be the
let
circular
rec
one.
in OCaml, I'll tell you what it's used for. At least if I understood OCaml, and I only have a very small experience with it. It's on the list of languages that I want to cover, but I'm never getting time for it. Um, it's uh it's the equivalent of labels in Common Lisp.
Okay.
So
I'm
labels
not
in Common
familiar.
Lisp is, as you are familiar,
No, I'm
is
not.
essentially, oh, so you can define functions lexically in Common Lisp, so locally lexically scoped functions, okay? But
Okay.
whereas in Clojure you can use let to actually define lexically scoped functions. In Common Lisp, you have flet and then labels. Flet is like let but for functions. All right.
Okay.
Labels is like let star in addition to allowing you to define recursive functions.
Okay.
So if you think of labels as let star, then it makes sense that you could define a recursive function because you're basically defining the function in terms of its previous self, right? So once the symbol is originally defined, then it can go look itself up.
Yeah.
There, so it makes sense that you could define a recursive function. So
Okay.
anyway,
So let's let's try to get back to so you just ran yours. Maybe let's try to get to the point where I can run mine.
yeah, that's
Uh
exactly why. That's why we are here. This is what
okay.
we are doing. All right. In this section, once you
Yeah.
have all this code written in main
Yeah.
and web server, the next
Yeah.
thing you want to do is go to your build script and first rename your build script from build.ros to samplewebapp.ros, just so that way,
So I will save this as sample web app dot rus. Okay. And
okay.
now
And now you just need to simply once you loaded it, right? So all you have to do is in main,
I don't know what you mean by I loaded it.
yeah, in quick load, you quick loaded the sample web app in your build script. So it's already you don't need to run a common Lisp REPL or
Y-
anything like this. At
you
the
mean
very
this?
bottom in the main function, yeah.
Oh. Yeah.
So if you did this, all you have to do is add the line sample web app colon start web server, and you're good.
After this form?
Yeah. The reason why
Sample.
you have to do it after this form
Oops.
is declare is basically telling Common Lisp when it's registering the function. By the way, we know that this takes an argv, but we're choosing to not use it.
Uh, oh, I see. So this is saying you can ignore this,
Yeah.
but this has to be there because the environment is going to supply it. Um,
Yes.
okay. So sample web app, start web server. That didn't autocomplete for me, so I'm thinking that maybe I didn't do something somewhere that I should have done. What about this stuff
The
up
only
here?
thing is if you didn't
Is this a
start, if you if you started your Lisp REPL and you didn't quick load sample web app in your Lisp REPL, Space Max will not autocomplete for you.
Yeah, I haven't done the REPL at all. Let me go back to what should I start the does it matter which one of these I start the REPL
No,
from?
it doesn't. It's irrelevant.
Okay. I'm starting it
And
from
then all you
main.lisp
have to do is just do a
with
quick load.
comma single quote starts this. So then I do a quick load
Yeah.
of something.
Sample web app
Sample in a string.
in a string.
Sample
Always in a string. Just
web app.
done. Okay.
Okay.
And
That
now if you go back
did
to your
stuff.
build script, you'll
Yeah.
see. Yeah.
Oh yeah, I don't have the same thing up here as you have. What do you have? Let me go back.
What are you
You have
talking
def
about?
package in package. Do I? Oh, there it is. Okay, cool. What is this number right here?
That's when Ross generates a build script, it generates a unique number there.
Okay.
I don't remember exactly what the reasons why it does that. Um, but that's just to make a unique package in your Ross build script, so everything is nicely and
Okay.
tightly packaged. So you
Okay.
don't pollute CL user when you run Common Lisp and you build common your packages.
Yeah.
You only pollute the Roswell namespace. So,
uh,
you want to
alrighty.
see autocomplete, right? So if you go into line 18 and try to delete that and then, try it again, it should give you autocomplete. Yeah, there you
A
go.
cool.
So now, you want to fire up a shell because you can't do ROS
Yeah.
build in the shell. I mean, sorry, in the Lisp REPL, as far as I know. Um, yeah, and then just do ROS build sample web app dot ROS. Yeah, that guy. Done. Boom. Dumping it. Golden. Start it up. Dot slash sample web app. There it is. Enter. It's running. Go and fire up your secondary shell to run curl, and then you're good to go. Yeah.
Yay.
Done. Well, that's root, right?
Uh.
That's the
Okay.
root. We don't have a root URL, right? We have to we
Yeah.
use
What was
yo. We have to say slash yo.
yo?
Yeah.
Hey. And then if I do yo question mark.
Yeah, yo question mark name equals Dave
Oh, how do I?
or name equals, Al, you know.
How do I get like complete
I don't know.
this and then type
EU
after it?
is one of those web browsers I don't use.
Yeah,
I'm
okay.
not
I'll just type it out. It took me longer to decide than it would have just to type it out. Okay. So then question mark name equals Steve. Did we call it
yes.
name? Is that the name of the parameter?
Yes, name
Yes.
equals
Okay,
Steve.
cool. Cool.
Okay. So we're
Oh,
now having
actually,
we
what if I do I it's meta p to get the most recent thing that I put here. So now I can add some more stuff, and there it is. Hey,
Yep.
cool. All right. So you were saying?
So what I'm gonna say is so now what we have with us is technically a the framework to just start um, writing a bunch of web APIs. Okay,
Yeah,
because whether we use
actually,
Clack
I
or whether we use Hunchintoot, because Clack again is has some nice utilities that I would like us at some point to refactor this code to leverage, just so that way we don't have to write all this cruft, because this is all boilerplate, right? Clack handles
yeah,
all of it for us. Um,
actually,
uh,
I have reverse now that we have this running on a port, I have a reverse proxy for my server that's actually on the web. So I could even actually put this in the
yeah,
real
exactly. If you use,
internet at this
I
point.
would prefer you use Nginx. Just,
Uh
but I know some folks like Apache still.
I mean, I already
Um,
have it set up with Apache. So for me it's a lot easier just to add one more thing
oh,
with Apache
right.
than it
I don't
would
know
be
if you
to
used, how long have you been using Apache out of curiosity?
like 20 years. Not that
Ah,
I am super well versed in Apache, but it's the one that was available when I started, and I just have kept
you
using it the
stuck
whole
with it.
time.
Right,
Yeah.
right.
I never really.
I stuck with it for a decade, and then I got roped into learning Nginx, and when
Yeah.
saw how much lighter weight it was, I was like, shit, why did I use Apache?
Yeah.
Oh man.
Maybe if I haven't really come across any like high load or anything, or like, oh man, if only Apache would stop going down. That hasn't really been an issue for me, but like I could see that happening, and then I would like look into what is this Engine X thing everybody's always going on about? um,
Yeah, no,
yeah.
a lot of web cloud services use Nginx. That's the main reason why
Oh,
I
okay.
ended up getting familiarized with it. Um, but if you have
But yeah,
Apache,
I'm not
you
opposed to.
certainly you can do
I
you
could
can
do a
set this up to start doing it,
I could
and
do a
you'll be
double
good.
reverse proxy. Set Apache to be the front reverse, and then send that some traffic on some port to Nginx, and then have Nginx send that traffic to Common Lisp.
Well, does out of curiosity, does Apache has a built-in load balancer, right?
I don't know. I've been running websites for myself and family and friends, so I haven't really had to
Okay.
worry about load balance. I don't. My like top concurrent users is maybe five,
Oh,
and
then okay, Apache is perfect for your use case. Never mind. I mean, I was just asking because
yeah.
that was the other reason why, like, our this was I was using Nginx for commercial development, and a lot
Although
of those
if
cases it has a built-in web load balancer, so I didn't have to write a separate load balancer,
yeah,
or grab a separate load balancer. So
I I hope that something I work on takes off and is a load balancer would actually make a difference
oh, you're
to
saying you want something that's load balancer worthy?
yeah. Like maybe the tax thing that I've been working on, and that like the other guy thinks I should rewrite in Common Lisp. Um, like something like that would
Oh,
be cool. He was saying
did,
that like what if you made something like this, and you you it didn't have to be just for the United States. You could have it go do tax for other countries as well. Um, and that seems like a cool idea. Like a huge project, but yeah, why not? Why
yeah, absolutely.
why is everybody spending resources on this thing? Like there's no fundamentally it seems like a much better use of resources to just have a commons thing that does that for us. I mean, if there's anything that the is really well suited to be a commons thing, it would be collecting taxes. Like that seems like the quintessential commonsy type thing. To
Well, I think for software,
yeah,
whether you are in the United States or in on another country, the difference is the damn form, but the ideas are fundamentally the same.
yeah,
So,
Yeah,
It's
actually, the
not
person I was talking to is in Wisconsin, so I went and looked at the Wisconsin form, and yep, it's basically the same thing.
right. Each state has some additional deductions that you
Yeah,
need to deal with, but fundamentally, if you're talking about the standard deduction for state or federal, it's the same effing form and the same process.
yeah, and but
From my
like,
understanding.
and they all have in common the concept of deductions and
Right,
additions. So once you
right,
have the mechanism worked out for one, then it's basically just tweaks.
right. And I
Um,
think you could certainly write that in Common Lisp pretty easily.
yeah, I'm thinking.
Especially
I,
if you have the fundamental design done for the back end. Um, the
yeah,
front
I
end
feel pretty good
is
about
going to
the
be
way that it's the back end is holding all the data structure. I have the data structure now, and that's the hardest part.
yeah, that's 90% of the problem. A good solid data structure is always
Or at
good.
least I have a data structure. Uh,
Right.
I'm sure I'll
So
keep thinking of improvements.
I want to
Yeah.
mention that
Okay.
I'm not going to go through Dockerizing this at this point, just because we're not quite there yet.
That's fine.
But at some point, I know a lot of folks are going to ask, how the hell do you Dockerize this?
Oh, okay.
And I
So
think that's
we could do an
important.
episode on that. An
Yeah,
episode.
and
I don't know what to call
I want
this.
to dedicate an entire episode on
Okay.
Dockerizing it because there's a whole philosophy when it comes to Docker containers that I have to revisit specifically for Common Lisp, especially with modern knowledge, particularly when you start talking about from scratch images and how you leverage from scratch images within the context of Docker, well, of Common Lisp. So if you start with, like, say, a top level SBCL image, but if the SBCL image is not Alpine or something like that, what does that what do you lose from it? Because if I want a very small Docker image, a lot of folks say that that's not standard practice anymore. You don't want small Docker images, but I'm like, why not? I want my images to be as a few megs as possible. You know, just so that
Yeah.
they could be running on the lightest cloud instance that I could get for free, but still be able to get 200 million followers.
Yeah.
you
It's
know.
gonna happen. It's totally gonna happen.
So I think it would be useful to actually do that kind of stuff for um, the sample for Dockerization. Um, yeah, that's it.
Cool.
So
Um.
um, I think the next thing is
Yeah.
I wanted to ask where y- where you want to now us to drive, because we now have the basic framework. We could do one more episode just on web servers just to get this into Clack. If you want us to deal with all this boilerplate, get rid of all this boilerplate that I showed you with the handler case
Yeah, that would be cool. We
and
could
stuff.
do an episode on like now that we've hand rolled, what would it look like to use a tool to do that stuff for us? That sounds
Right.
cool.
And I think once we do that, we would be finished. We'd put a nice bow on this particular section of web development, which is
Yeah,
setting up the infrastructure for a new
skeleton,
project.
scaffold, whatever.
Yeah, the
Yeah.
scaffolding. And then we could start actually talking about a real app and start
The
building it live.
Yeah, the very next thing that I want to do is you determine like have a login and
Yeah.
have like it could even
Up,
just be a page that says you are or are not logged in and that's it.
right.
Oh, and I guess
That's the next step.
enough form to allow you to enter your login credentials. I'm not exactly
Correct.
sure, but something. And then I guess
No,
you would
I get
also
it.
have to have a database, or you could have Yeah,
We
probably a
can
database. Yeah.
we'll start with the database first, but ideally,
Yeah.
I think as we evolve this application, the modern knowledge approaches is to eventually use OAuth at some point to do the authentication once we start doing more services. But
Yeah.
I think for a simple
It,
login, it's just a database.
yeah. And then
Yeah,
another thing we could do is like redo what we've already done. But since we've done it, we could do it way faster in theory. And
sure.
I like doing that because that helps me get to the point where I have like a thing that I want to do, and then I am fairly confident that I can make it happen. Excuse me. I think if you held a gun to my head and said like make sample web
Do
app
this in
like this,
Common Lisp, it would be hard for you. I know. I know where you're going with this,
cool.
and where your head's at, and I completely agree. Even today, I would make the argument that I have the same problem. So,
I feel like
yes,
I
we
feel
could
like
totally
if
do
I
that.
put a gun to your head, or if someone hypothetically put a gun to your head, you could probably make it happen. I don't know if I could without like looking stuff
So,
up.
here's the one thing I will
Yeah.
say, and that is, I've been working on and off of Common Lisp for over, it's now officially 19 years.
Nice.
Because 2006 is when I was introduced to Common Lisp. It's now 2025. All right.
Yeah. That's 19 years. I
But
don't know when I first
I didn't
tried.
seriously start doing Common Lisp until 2016 when I started my web series on
Oh,
Common
okay.
Lisp. So it's been 7 years where I really delved into Common Lisp and proper Common Lisp development,
Yeah.
and honestly, from 2006 to 2016, the game was very different. Even though we had ASDIF,
Yeah.
Quick Lisp didn't exist, Clack didn't exist, Ningle didn't exist. Hunchitude was used for some very nice small projects, but it really got a boost when ITA started using it for their airline reservation system. Um,
Oh, interesting.
uh, and it just was very difficult to do what I would consider basic infrastructure management for a large scale project. All right. If you didn't know what you were doing for years after years of doing pain, starting something new with it was very difficult. Okay. Although there was a lot of blogs in those early days because we had folks like Lemon Odor still available, doing stuff. There, Bare did some really great work with his work in Common Lisp before he decided to jump ship and switch over to Racket. He's doing a lot more stuff in Racket now. He does occasionally look at his old Common Lisp code. He's the guy who designed Bari actually is the one who designed Quick Lisp. Yeah, Fari
Nice.
designed Quick Lisp, but somebody else took it over since he did, and Zach is the one who's been maintaining the project now. Um, and then you had honestly the real improvement started right around that I started the Common Lisp study group because that's when Fukamachi started releasing a shit ton of libraries. Like half the libraries I use are from him. Like literally half the libraries I use for l- general Lisp development are from Fukamachi. All right, like that dude is a beast. All right, he is a beast when it comes to those guys in Japan are no joke. Shout out to the folks in Japan when they did because of the work that they did with Common Lisp. They really kept it alive and going. You know. So yeah. Um.
Apparently, I haven't been committing this. I thought I
Congratulations.
had,
Good
but
job.
oh well.
That's okay, buddy. You can commit
Init
it and then throw it up
repo.
there and yeah.
Um, yeah, cool. All right. Well, I think that's good for me. I'm gonna go to sleep. Good night.
Wait,
See
you're
you next Friday.
see
What's
you
up?
next Friday, buddy. I'll see you
Yeah.
later.
Good times.
Bye.
Well, I guess first I'm gonna upload this and then I'll go to sleep.
Yeah.
All right. Bye.
Wait. You're
Yeah.
going to sleep. Wait a second. It's like 8 o'clock, right? There.
Oh yeah. I guess I'm not gonna go to sleep immediately. I do go to sleep at like 9 p.m. though.
Oh, perfect, man. Good
Yeah.
job. All
Yeah.
right. Have fun. See ya. Bye.
Bye.